Hello everyone. Today I will talk about solenoid valves and I will make a presentation about the purpose of solenoid valves and also solenoid valves, what kind of solenoids do we manufacture in the TORK company. First of all, I want to introduce what is a solenoid valve. Solenoid valve is an electromechanically operated valve. So in solenoids, what we have is one coil, one core, one tube, and the body of the solenoid. And it's controlled by electric current through a coil. It is very wide range of use, mainly up to 2-inch flow control business. We generally use solenoids since they are compact and also cheaper than the other solutions. Many kind of different application areas we can use solenoids. So the target of the solenoid valve is shut off, release, doors, distribute or mix the flow. And solenoids offer generally fast and safe switching with high reliability, long service life and low control power and compact design. So there's a picture now for the solenoids. Do they see this picture?
Yeah.
Okay. And in the solenoids, you will see the part numbered with 4 is the coil, and with the 5 is the winding. So this coil, when we give energy to the coil, it creates an electronical place around itself, and by this force the 7 numbered core goes up and it opens the orifice, which is shown by number 9. So when we give energy to the solenoid, we open the orifice and flow keeps flowing by this. It is the basic mentality behind how solenoids works. But in deep, solenoids differentiate in according to application and also its size. So mainly it divided 3 different types. One is direct operated. In direct operated version, we directly close orifice with core, as you see the picture now, like the part numbered with 7 directly closes the orifice. There's another kind of solenoid which is pilot operated. So if you make the bigger size, bigger than 3/4, 3/8, half inch, 1 inch or 2 inch. So we use this kind of solenoids. It's because of the physical rules. I will go on deep in the next slides. And also, if there is no differential pressure in the pipeline, in this case we should use servo-assisted solenoids. I will focus on deeply in the next slides each of these valves. So first of all, I want to talk about what is the difference between direct operated and pilot operated valve. So as you see, the left side there is a direct operated solenoid valve. In this case, we directly close the orifice of the solenoid with the core. What is the advantage of this? So if the size of the solenoid connection is 1/8 or 1/4, in this case we can use these compact solenoids. So in terms of price, it will be cheap. In terms of size, it will be much more compact. But the disadvantage of this solenoid, you will have less flow rate. So if you go up bigger than 1/4 inch, then we should also increase the size of the core. And in this case, you should use bigger coil if you want to operate it directly. So Bigger coil means bigger energy consumption, and also it will cover bigger space inside the machine. So instead of this, we prefer pilot operated solenoids. The mentality of this solenoids, in this case, we close down the orifice with the diaphragm. In the picture also you will see there is a diaphragm here, which is, you will see the black diaphragm. So on this diaphragm there is a hole which is 0.8 or 1 mm diameter. The flow comes up through this hole and it goes up to the hole next to the core. So when we give energy to the core goes up and it opens this hole. So we create a flow difference between upside of the diaphragm and downside of the diaphragm. So this is a basic physical rule. If there is a flow speed difference between 2 points, the pressure drops. So the pressure in the upside of the diaphragm drops. So this diaphragm goes up and the flow continues flowing through the gap between diaphragm and the orifice in the downside. So in this case, we can use smaller coils to operate the valve, but we can get good flow rate, enough to control our machines. If you talk about the initial position of the valve, there is two types of solenoids. One of them is normally closed and the other one is normally open. Normally closed valve is if there is no energy in the coil, valve is closed. So there is no flow if you don't give any energy. If we give energy, valve opens and it continues to flow. The normally open solenoid valves is just opposite of this. So if we don't give energy, it means there will be flow, and if we give the energy to the solenoid, then it will close down the valve and it will stop the flow. So there is now some pictures of both type of solenoid. So it is picture for normally closed type. So you will see in the left side picture when the power is off, so there is no flow, and when we give energy to the coil, then core, this part goes up and the flow continues itself. And the next slide. In the next slide you will see the normally open type of solenoids. So in this case, you will see if there is no energy, then the flow continues. And if we give the energy, it's shut down to the flow. So it depends on where will we use the solenoid. In some cases, customer asks for normal open. In some cases, they say we need normal closed. So it depends on the process you will make. Choose of this kind of solenoid. If we use pilot operated ones, again it has the same mentality. So we are using the inline pressure difference both sides of the diaphragm up and down. So when we open the valve, we decrease the pressure as I explained the last slide, so it continues the flow. As you see, when I give the energy, I open this point and you see the flow continues on this hole. So I create a flow speed difference between upside of the diaphragm and downside of the diaphragm. So what happens is, since there is a speed difference between the speed difference of the flow up and down, and this diaphragm goes up and flow continue through this hole between the orifice and the diaphragm in the downside. If you talk about a normally open pilot operated valve, there is two types of this. One is with the pipe and one is without pipe. The difference is the pressure. So if you want to go up to 70 bar, we have to use normal open solenoid with pipe type. The disadvantage of this kind of solenoid is the space. If you have enough space, you can use this one. But if you have limited space, and if you don't have pressure problem or your maximum pressure is just 10 bar, you can prefer without pipe type. So first of all, I want to explain the working principle of without the pipe type. As a result of the mechanical design of the coil, if we don't give any energy, this hole here continues open, and since there is a pressure difference between up and down side of the diaphragm, so flow continue. When we give energy, we shut down this hole here, and so we stop the flow upside of the coil, upside of the diaphragm, and as a result of this, it shut it down by physically. So if you want to go up to higher pressure level, so we prefer this pipe type. So instead of this mechanical design in the core, we make this flow through this pipe. So with the same mentality, we keep the flow go on the upside of the diaphragm, so it is open, and when we give the energy, we shut down this hole here and we stop the flow. So you see, when we give the energy, we shut down this hole here, and there is no flow in the upside of the diaphragm, so it stops working and it doesn't let the flow go. There is a very important point in the solenoid valves. In general purpose solenoid valves or standard solenoids, and if it is pilot operated, you need minimum 0.5 pressure, 0.5 bar pressure in the line. So what is this? It should be differential pressure. So from inlet to outlet, there should be 0.5 differential pressure. If it is direct operated, you don't need this, but in pilot operated, since as I explained in the below slides, this pressure difference issue between the upside and downside of the diaphragm, we need this 0.5 bar difference. So you see, if it is pilot operated, you should need my minimum 0.5 bar difference. But if it is direct acting, it's not a problem. So both sides of the valve can have same bar or same pressure level. So if in our pipe, our process, if we don't have differential pressure, or there is a risk of zero differential pressure, but we have bigger sizes like 2-inch, 3-inch, and we want to use solenoid valve. So in this case, there is a third option, as we say, servo assist solenoid valve. It can be only used as normally closed. So in this case, we are using bigger type of coil, and when we give the energy, this coil directly connected with the diaphragm. So with the power of the coil, we go up mechanically this diaphragm up. So we don't use this differential pressure issue in this case. So we are just using this mechanical connection between the diaphragm and the core. So we open the valve. So you can ask the question, you can always use this principle to work or to run the solenoids, but it increases the prices and the space also, increase the cost since we have to use bigger size of coil. So if the customer has minimum 0.5 differential pressure, we offer them pilot operated, but there is a risk of this differential pressure, so we offer them to use this servo assist solenoids. Another kind of classification is the way. of the solenoid, how many way does it have? Normally we use two-way. And what is it? It has an in and out side of the valve, but sometimes some customers want to use to operate a cylinder, or they want to open and close a piston with the solenoid. In this case, you have to use two-way. So you can drive a piston, actuator, or that kind of pneumatic device with this type of solenoids. So there's a chart or explanation what kind of properties or specifications our solenoid has. So in secret connection we have from 1A to 3-inch solenoids, but if you want to make it with flange, so we have from the N15 to the N200. The ambient temperature we can offer -20 or 80 Celsius, but for specific application we can offer up to -50 for ambient temperature. For the flow we can again offer from -10 to 160, but we have also special series for instance cryogenic flow, so up to -196 Celsius we can offer solenoids. Maximum pressure we can go up 100 bar now, but it is related with size. We can reach 100 bar with 1/8 and 1/4 inch size. So up to 1 inch we can go up maximum 70 bar, and bigger than 1 inch we can go maximum 16 bar. Maximum flow rate value is 14,600 liter per minute, and maximum flow viscosity is 37 cents. TORK is an important issue. So, as I explained before, this differential pressure issue, and there is the whole issue on the diaphragm. So we need low viscous solenoids, sort of low viscosity fluids to operate the solenoids. Other case, if you use something like honey or something with the dirt inside, the solenoid doesn't work properly. So the sealing material we use is NBR, APDM, FKM, PTFE, and rubber. So any kind of application for air, steam, gas, vacuum, and compressor, fuel oil, or acids, or aggressive flows, so we can offer a product to you. So body material we use is brass, stainless steel, and PVC plastics. The coil voltage, since we manufacture our own coil, we can manufacture the coil according to your request, but in standard we have in AC 12, 24, 48, 110, 230, 380, and in DC we have 12, 24, 48, and 110. This is the coil insulation class each H, so it's something technical. So continuous on DATI or solenoid can work, so you don't have to cut the energy 3 months, even you don't cut energy and you give the energy to solenoid, it will work without any problem. And in the protection class, what we can offer IP65 in standard, IP68 on request for underwater application, and also M-type and D-type EX proof. D-type and M-type, both we have in the coil. This is flow rate issue. It's something technical, but not so much important. So, if you are interested in how to choose a solenoid, first of all, you should ask the size of the solenoid to your customer, and after that the pressure, and after that the working condition, like is it will be direct operated, pilot operated, two-way, three-way, or normal open and normal close. After we learn this, we will learn for fluid type, so we can choose the sealing material inside, and also the fluid temperature. And after that, according to this information, we choose, but the material selection, or sometimes customer requests from you, please use this material. So as I say, we can do it brass, stainless steel 304 or 316, and also plastic PVC, and also the viscosity rate and flow rate is important. And after that, the working voltage. So all this information you can choose the solenoid. Some advices for the connection. So the first picture and the picture in the middle is the correct, but we don't prefer to connect it to the downside to the coil. So we generally prefer to connect the coil to look up or vertical, it can be, but not the down. So another tick is in the pilot operated solenoids, since there is a small hole, you can see on the picture this small hole, and if you don't want to stick it up, so stick it or close it, we offer our customer put a filter in the entrance of the solenoid, and the flow or the fluid which passes through the solenoid should be very, very clean. Even just small dust can block this hole because it is just 0.8 mm diameter, so it will be malfunctioned, it will not work after this. So how to mount the solenoid? Not with hands, always use proper tool to do this. So another key point, do not give energy to the solenoid, to the coil, if it is not connected to the valve. This is important, you can easily burn out the coil. For the next info, the coil can be hot, even you cannot touch the coil. This is normal, it can go up to 80 Celsius. And the power connection should be done by authorized person. So if you make it open connection, it may cause electric shock or short circuit. So the fuse line always should be connected to get rid of the risk of any kind of leakage or short circuit faults. So in critical application like electronic cars, coil must be operated through a relay. In this case, you can protect your board, electronic board, from any kind of burnout if you use a relay. We offer this. Another product, it is related with solenoid mentality, but it has special application for jet pulse filters. Name is pulse valve or dust collector valve. So it's a kind of shock valve, and it is just used in jet pulse filter systems, and it uses to shock the filters inside the jet pulse, so you can clean the filter inside with this shock valve. So we have starting from 3/4 to 3 inch and up to 0.5 to 8 bar pressure to two-way, normally closed. And flow temperature maximum 8 Celsius, but ambient 50, and IP65 and IP68 is available, and the cast aluminum body we are using, and for diaphragm we are using special type of APR. So these are some pictures from 3/4, 1 inch and 1 1/2 inch. So according to your connection, we can offer coupling or flange connection to you also. And we guarantee 3 millicycle life with the high performance with our solenoids. Sometimes they say, instead of doing this kind of blue tank in the glove, we want to offer you with the tank, and we call it pulse tank. So according to the jet pulse filter manufacturer request, we can also build up this tank also.
Thank you for everybody. Now we have another presentation, and I am open now another presentation. Yeah.
So in first presentation, I talk about the working principle or the working technique of the solenoids. So in this presentation, I will explain about what kind of solenoids do we have, and I will talk about the series of solenoids. So S10 series is our general purpose series. So we offer for air, water, and non-aggressive gases, this series. So we can go up maximum 100 bar, but it depends on the size. So inside of this series also we have low energy consumption series like black coils. And also, if there is not enough differential pressure, so we can use this S1020 series. S1021 is normally open and S20 is normally closed one. So in the same general purpose S10,000, so S1000 series is servo assist ones. S1015, S1016, S1018 is 3 two-way solenoids. It has different working principle. Each series you can see below the pictures. So the other main series is S20 is steam, S30 is vacuum application, S40 is fuel oil application, S50 is compressor, and S60 is stainless steel. So one of the advantages, our coil is interchangeable, so you can change the coil one to others. And also all these series we can make it ATEX, EX proof also. If we talk about the special valves, for instance, one of them is S91 piston solenoid valve. We use it for PET blowing machines, especially the latching solenoids. If you want to use low consumption electricity, there is a magnet in the top of the tube, so it's only controlled by DC voltage. So when you give the energy to the valve, you don't give it continuously, just once a time. If you give, it will keep open, and when you change the poles of the current, it will goes down. For the refrigerators, we have S61 and S62. For irrigation, for the parks or grass, other stuff, we have S89 series. For oxygen and hydrogen, we have S8080. And for aggressive flows, we have S84. And for especially it's used for hygienic application, or if you don't want to get in touch of a solenoid with the flow of the pinch solenoid S85. And for the regulation, we have S29. For the compressor plate, we have special solenoid S5071. It's designed according to customer request. If you need a group solenoid, S84, 82, and if you want two-step for a fluid oil dispensers, we have S7030. In some applications, customers ask for underwater application solenoid or for aggressive places. So in this case, we have PTFE coated solenoid or chrome nickel coated. For EX environment, we have SX series. So the flow is not important. We can change the inner sealing material according to your request. Maybe you will remember in the previous slide, I talked about if there is some dust in the flow, and you cannot operate the solenoid in a good way. So to deal with this problem, we designed a new series with filter on the diaphragm S4073 series. So in this case, we put a filter in the diaphragm before this small hole 0.8, so the dust or any kind of sand inside the flow stops by this filter, and it doesn't affect to the solenoid valve working. It is something special. According to the request, we can deliver like that. Again, for special solenoid, we do it for blood analysis or for track and brake solenoid valves. And the coils, what we manufacture is SC40 in standard and C50 for servo assisted solenoids. For AX environment, we manufacture S41 or S43. For waterproof IP68, we have S42 or film welding diode. It's for not to burn out the electronic circuit before the coil. This is just for the safety. S44. And also we have small series. We do not manufacture the smalls, and it's non-magnetic coil. And the connectors, any kind of connectors, and also the timer we have. In some cases, customer needs low consumption, so we have PWM connectors for this specific reason. So in DC coils, it can decrease the energy consumption up to 85%. So this shows the mentality. The most important part in the solenoid to open the valve. So this PWM connectors, it has electronic circuit inside, and in the beginning, in the opening, it takes the bigger energy, but after that, it keeps the energy in a lower frequency. So you don't have the same amount of energy open the valve and keep it open. To keep it open, you have less, but to make it open, first movement, you have the biggest energy. So after this, you can decrease up to 89%. So this is two slide. Thank you for your all watching. Any question I can reply.
Thank you for everybody your attention. Now, is there any problem to sharing presentation for PDF? Okay. Now I am sharing the presentation for PDF file. I am sharing both of them. You can download on chat section. And now I am open the chat. And if you have any question, you can write on the chat section. Lastly, I want to say you can follow our social media accounts. Okay, now chat is open. Is there any question? Please write on the chat section. I am sharing our presentation now. Mr. Ali has a problem for STEM application. S20 is a use, right?
Yes, that's right. Yes.
Yeah, Mr. Ali, it's true. Thank you for your question. Is there any question now? And Mr. Ali asked again, what about the steam hammer risk there?
Actually, there is no steam hammer, but first of all, I want to answer the Ali question. The steam hammer and also water hammer, we say. In some lines, in some pipelines, we have water hammer effect. So for the solve this water hammer effect in solenoid, we have water hammer series solenoids. So it has a special design to eliminate water hammer effect in the solenoid. So in this case, if you are afraid of water hammer effect in your solenoid, you can ask for, we have this kind of problem, can you offer us a special product, so we can offer it. And the other question with Mr. Güven, may you mention pressure drop some of these valves? Yes, exactly. There are huge amount of pressure drop all these valves, because it is not since it's floor files. What does it mean? If you, in the entrance you have in the pipe, for instance, 1-inch solenoid means the 25mm pipeline, and also the orifice is 25mm. You see in the pilot operated valve, especially, we are using this diaphragm, and diaphragm goes up and the flow continues through the gap between the diaphragm and the orifice. So it is not like a ball valve, so it doesn't 100% open anytime. So there is a pressure drop, of course. And we have lists for these pressures, and you can check how much pressure will drop in your application through this list. We can share it with this, or you can check from our website also.
Thank you, Mr. Güven, for your question. Is there any question about webinar or products? Thank you for everybody for your attention. Now, can you share your email address? Maybe somebody ask question later. Now, Mr. Ömer, write your email address if you have any question or if you need any products. You can send email, Mr. Ömer.
Please do not hesitate to ask anything about this, so you can directly write to me about these questions.
Now we are waiting for your question. Yeah, okay, lastly, do you have any words?
Thank you very much for everything, for joining this webinar. We will continue to doing this. So any question, please get in touch with us through our email address. Thank you very much for everything.
Now we have a small survey. Please fill the form because we want to develop ourselves. We wait your comments. Okay, we wait now. If there is any problem or if there is any question, we wait now. There is no problem. Okay, thank you for everybody. Now we open the survey, and after 10 minutes we close the webinar. Thank you for your attention.